Have you ever considered the vast differences between a teacher guiding a student and a child exploring the world on their own? Just as humans learn in varied ways, machines too have their unique approaches to learning. Welcome to the intriguing world of machine learning, a subfield of artificial intelligence, where we teach machines to learn and make decisions, much like us humans. In machine learning, there are two main types of learning: supervised and unsupervised learning. Like two sides of the same coin, they are different yet connected. Each has its unique strengths and weaknesses, and understanding these differences can help us harness the full potential of machine learning. Let's start with supervised learning, where we play the role of a teacher. We provide the machine with a set of examples, each paired with the correct answer or output. The machine then uses this training data to learn the relationship between the inputs and outputs. It's like a teacher giving a student a set of math problems with solutions. The student learns the method using these guided examples and then applies it to solve new problems. But what if there's no teacher? What if the child is left to explore the world on their own? That's where unsupervised learning comes into play. Here the machine is given a set of data without any labels or correct answers. It's like a child exploring a garden full of different plants and insects, learning to classify them based on their similarities and differences. The machine in this case learns to find patterns and relationships within the data on its own, without any guidance. So, in this video, we will delve deep into the fascinating differences between these two types of machine learning. We'll explore how they work, their strengths and weaknesses, and their real-world applications. We'll also discover how they are shaping our future, from improving our healthcare to making our cities smarter. In essence, supervised learning is like having a teacher, while unsupervised learning is like exploring the world on your own. And just like in life, both these learning methods have their unique roles in the grand scheme of machine learning. Imagine having a guide when learning a new skill. Wouldn't that make the process easier? That's the principle behind supervised learning, one of the key methods of machine learning. In supervised learning, the AI system is provided with labeled data, meaning the data comes with a guide or a teacher, if you will. This teacher is nothing but the desired outputs or the correct answers to the problems at hand. Let's say we're teaching a system to identify images of cats. We'd provide it with numerous images, each labeled as cat or not cat. The system then uses these labels to learn the characteristics that define a cat. Over time, the system gets better at identifying cats, even in images it has not seen before. Now, where does supervised learning find its application in the real world? The answer is almost everywhere. Take email spam filters, for instance. These filters are trained using a set of emails labeled as spam or not spam. Over time, the system learns to differentiate between the two, helping keep your inbox clutter-free. Another great example is in the field of medical diagnostics. Machine learning algorithms can be trained to identify diseases by analyzing medical images. They are fed with images labeled with the presence or absence of a disease. And over time, they learn to identify the disease with high accuracy. One vital thing to remember about supervised learning is that the quality of the output heavily depends on the quality of the input. In other words, the better the labeled data we provide, the better the system will perform. So supervised learning is like having a personal tutor. This tutor, the labeled data, guides the system through the learning process, ensuring that it learns correctly from the start. It's a process of learning by example, where the system learns to make predictions based on past data. So supervised learning, in essence, is the process of learning under guidance. Now think about a child exploring the world, learning things by observing and experimenting. This kind of curiosity and thirst for knowledge, in essence, is what unsupervised learning is all about. Unsupervised learning is a method of machine learning where the AI is left on its own to discover hidden patterns and structures within unlabeled data. Without any predetermined labels or categories to guide it, the AI must explore and experiment, much like our hypothetical child, to make sense of the data it is given. Consider a box of colored blocks. In a supervised learning scenario, we might tell the AI, these blocks are red and these blocks are blue. But in an unsupervised learning scenario, we don't give the AI any information about the colors. Instead, We simply give it the box of blocks and let it figure out that there are different colors on its own. In the real world, unsupervised learning is used in a variety of applications. For example, in market segmentation, unsupervised learning algorithms can analyze customer data and identify distinct groups of customers with similar buying habits. This allows businesses to tailor their marketing strategies to each group effectively. Similarly, in the field of bioinformatics, unsupervised learning is used to analyze large sets of genetic data. By identifying patterns and structures in the data, researchers can gain insights into genetic diseases and potential treatments. But perhaps the most crucial aspect of unsupervised learning is its emphasis on exploration. Just like our curious child, the AI and unsupervised learning must explore and experiment with the data it's given. It must make its own discoveries, draw its own conclusions, and in doing so, it can uncover hidden patterns and insights that might otherwise go unnoticed. In a nutshell, unsupervised learning is the process of learning through exploration. It's about giving the AI the freedom to discover, to find its own way in the complex and often chaotic world of data. And in doing so, it opens up possibilities for new and unexpected insights. Now that we know the basics, let's pit supervised against unsupervised learning, shall we? When it comes to approach, supervised learning is like a well-guided tour. The algorithm is given a clear path to follow with input-output pairs that show it exactly what it needs to learn. It's like going on a hike with a map and compass, knowing your destination right from the start. Unsupervised learning, on the other hand, is more of an adventure. The algorithm is dropped into the wilderness of data with no map or compass. It must find its own way, discovering hidden patterns and structures without any pre-existing labels or directions. It's like exploring an unknown forest, finding your own path as you go along. As for data requirements, supervised learning demands a lot. The algorithm needs a large amount of labeled data to train on. It's a bit like a student preparing for an exam. The more past papers they have to practice with, the better prepared they are. Unsupervised learning is more flexible. It can work with unlabeled data, making it a great choice when you have a lot of information but not a lot of time or resources to label it. It's like a detective piecing together clues, trying to make sense of a complex situation with limited guidance. In terms of applications, both types have their unique strengths. Supervised learning excels in tasks where we have a clear goal and plenty of labeled data, like predicting house prices or diagnosing diseases. Unsupervised learning shines in exploratory tasks, like customer segmentation or anomaly detection, where we're not sure what we're looking for but know there's something to be found. As we can see, both types of learning have their strengths and weaknesses, and their uses vary depending on the situation. So, whether you're going on a well-guided tour or embarking on an uncharted adventure, remember that the journey of learning is just as important as the destination. Ever wondered how important the data is in these learning processes? Well, it's like the fuel to a car, the ink to a pen, and the wind to a sail. Without data, machine learning is like a bird without wings. But not all data is created equal. The type of data used can greatly impact the learning process and its outcome. Let's dive into this a bit more, shall we? In supervised learning, we use labeled data. Think of it as a teacher-student scenario. The algorithm, the student, is given a data set where all the answers or labels are provided. The teacher, in this case, is the data scientist who provides the algorithm with the correct answers. The algorithm learns from this labeled data and applies this knowledge to new unseen data. It's like learning math from a textbook with all the answers at the back. On the other hand, unsupervised learning is a bit more adventurous. It's like exploring a new city without a map. The algorithm is given a data set without any labels and is expected to find patterns and relationships within the data on its own. It's more of a self-discovery journey. The algorithm is like an explorer, venturing into the unknown, searching for hidden treasure within the data. But here's the catch. The quality of data, in both cases, is crucial. Garbage in, garbage out, as they say. In supervised learning, if the labels are incorrect, the algorithm will learn the wrong lessons. It's like studying from a textbook full of errors. In unsupervised learning, if the data is noisy or irrelevant, the algorithm might end up chasing shadows, finding patterns that don't really exist. So you see, data is not just important, it's the lifeblood of machine learning. It's the foundation upon which these algorithms stand. It's the raw material that these learning machines need to create knowledge, to gain insights, and to make predictions. So the type of data used can greatly impact the learning process and its outcome. Now let's take a look at how these learning types are used in the real world. To start with supervised learning, it's akin to a student learning under the guidance of a teacher. This learning type is everywhere around us. For instance, in email filtering systems, supervised learning algorithms are used to classify emails as spam or not spam. The system is trained with a set of emails labeled as spam or not spam. This training enables it to classify new emails accurately. In the healthcare sector, supervised learning is a game changer. Predictive models trained with historical patient data can forecast potential health risks, enabling timely intervention. An example is predicting diabetes or heart diseases based on variables like age, weight, and genetics. Switching gears to unsupervised learning, think of it as a child exploring the world independently, discovering patterns and making sense of things. It's used in customer segmentation, a common practice in marketing. Here, unsupervised learning algorithms sift through customer data, identifying patterns and grouping customers with similar behavior. This understanding helps businesses tailor their offerings, enhancing customer satisfaction and loyalty. In the realm of social media, unsupervised learning plays a crucial role in recommendation systems. Ever wondered how a video streaming platform suggests movies that you might like? It's the magic of unsupervised learning, analyzing your behavior and preferences to recommend content you'd likely enjoy. And let's not forget anomaly detection, a vital application in cybersecurity. Unsupervised learning algorithms monitor network traffic, identifying unusual patterns that may signify a cyber attack. This early detection allows for swift response, safeguarding systems from potential threats. In essence, supervised learning excels in scenarios where we have clear labels and desired outcomes, while unsupervised learning thrives when we need to uncover hidden patterns and correlations in data. As we can see, both types of learning have a wide range of applications, making them indispensable in the field of AI. So after this journey through the world of machine learning, what are the key differences between supervised and unsupervised learning? To start, supervised learning is like learning with a teacher. The algorithm is trained on a predefined set of examples, which helps it understand and learn the patterns in the data. It's like a student learning math. The teacher provides the student with problems and solutions, and the student learns how to solve similar problems in the future. It's a direct approach where the outcomes are known and clear. On the other hand, unsupervised learning is akin to learning by exploration. There's no teacher, no right or wrong answers. The algorithm is given data, and it's up to it to find patterns and relationships. It's like a child exploring a forest, observing and learning about the environment by interacting with it. This method is more about discovery and less about reaching a specific outcome. One of the significant differences between the two is the data they require. Supervised learning needs labeled data, meaning the input data must be tagged with correct answers. Unsupervised learning, however, works with unlabeled data. It doesn't require the data to be classified or categorized beforehand. Another key difference is their goal. Supervised learning aims to predict outcomes based on known results. It's all about making accurate predictions. Unsupervised learning, however, is more about finding hidden patterns and structures in data. The goal is not to make predictions, but to gain insights and understanding from the data. Lastly, the applications of these two types of learning are quite different. Supervised learning is commonly used in applications where historical data predicts future events, like credit scoring and weather forecasting. Unsupervised learning, on the other hand, is used in exploratory analysis, or when we don't have a clue about the outcome, like discovering customer segments in marketing data or detecting abnormal behavior in network traffic. In conclusion, whether it's learning under guidance or through exploration, both supervised and unsupervised learning have their unique roles in shaping the world of AI.